Hello, welcome back to my channel. This tutorial is about voltage dividers. A voltage divider circuit uses resistors to reduce voltage. You can use voltage dividers to do a lot of things, like create a volume control circuit or generate reference voltages and much more. If you apply Ohm's law in this circuit, by running it, you'll find that 1 volt spread across 2 equal value resistors give you half a volt in the middle. So you are getting half the voltage. And as you would expect, 4 equal value resistors would give you 1/4 volt, 2/4 volt, and 3/4 of a volt. For the sake of simplicity, let's just use 2 resistors. If you use 2 resistors of different values, the voltage gets divided up in proportion to the amount of resistance there is. In this example, with 20% of resistance on the bottom, you get 20% of the input voltage on the output. If swap the position of these resistors, now with 80% of the resistance on the bottom, you get 80% of the input voltage on the output. By the way, voltage dividers will work fine with both AC and DC input voltages. And this is the equation you should use to calculate the output voltage depending on the resistors you are using. Vout equals to V in multiply to R bottom by R bottom plus R top. And if you are not getting the output voltage that you want, try the equation with some different resistor values, or rearrange the equation. Alright, here are some more examples. Here I am taking 10 volts and dividing it down to 1 volt. Here I am taking 5 volts and dividing it down to 4 volts. And here I am taking 100 volts and dividing it down to 1 volt. You might have noticed, I am using extremely different resistance values here, sometimes a few ohms, sometimes a few mega ohms, but it is ultimately the ratio of resistance values that determines the output voltage. Now that does not mean that, when you build a real-world voltage divider, you should use low-value resistors. Whenever you create a voltage divider, you have to be aware of the overall power consumption of the circuit. And you calculate it using this equation. With this circuit, the resistors are dissipating 0.1 watts, which is very little, so everything is fine. But in this circuit, the resistors are dissipating 1000 watts. So the resistors are going to catch fire. The output voltage the same in both cases, but power consumption is totally different. Also, before you create the voltage divider, you have to be aware of how much current your voltage divider has to supply, because voltage dividers are not the same thing as regulated power supplies. There is going to be a voltage drop as soon as you connect your device to the voltage divider, depending on how much load there is. For example, here is an unloaded voltage divider giving me 5 volts. When I connect a microcontroller that draws just 1 milliamp, the voltage drops to 4.56 volts. And that's not so bad, the microcontroller will still work. But if I try to power this motor that would normally draw 100 milliamps from 5 volts, the voltage drops down to 0.5 volts, and the motor won't work. So this voltage divider would be a terrible power supply for the motor. In general, you shouldn't be using a voltage divider if you have to supply more than 10 milliamps. But if you want to screw around with resistor values and see what you can get away with, you can calculate the Thevenin's equivalent resistance of the voltage divider using this equation. And yes, it also happens to be the same as the parallel resistance equation. Once you have calculated the Thevenin's equivalent circuit, you can calculate how much voltage your load is going to receive using the voltage divider equation from earlier. Now, what are some real-world circuit where you could use a voltage divider? Well, an easy one is a volume control circuit that you could use before an amplifier. And all you are doing here is just dividing voltage with a potentiometer. So look forward to more videos where we will do some more demonstrations. Thanks for watching this video and don't forget to subscribe to my channel.